All right. My name is Krauss. I'm going to be talking about F# today. I gave a talk similar to this at the .NET meetup back in June, I think it was June. If you came to that, you'll see a lot of the same things, but there's a good chunk different too. Like Jordan said, whenever pizza gets here, I'm always the first in line for it, so you know I'm going to break as soon as it's all set up. So let's get to it. I've got a couple shirts here. I throw out shirts. That's me. I'm the code boss on Twitter, Instagram, most other places. I work at a company called Clevyr. My buddy, John Pettigrew over there, works there too. And Clevyr does a lot of consulting. We work with a lot of companies locally, but we just kind of created Clevyr Labs, and there's a big chance you've heard me talk about Clevyr Labs at this point. All right, whenever that gets set up, we'll dig in. But Clevyr Labs focuses specifically on virtual reality and augmented reality games and applications. We've got a couple things in the App Store right now. It's a lot of fun stuff. So I've got 3 extra large shirts that I'll throw out. You got to answer my questions, though. That's a little bit later, though. So that's still getting set up. So disclaimer, before we begin, I am not an F# guru by any means. I don't use it professionally. The reason I'm giving this talk is because I wanted to challenge myself to learn it, and it's kind of, the best way to learn something is to put a fire under your butt and sign up for a talk. So it's been about 5 or 6 months of me playing with it. So I feel very comfortable with it, but there's going to be a lot of questions that you may have that I'm just going to flat out say I don't know. Do we have any F# gurus in here? Or people who are familiar with it? All right, so I'm the smartest one here. Anyway, disclaimer. All right, I think pieces are good to go. Let's hop on that. Break. All right, 1-minute warning. Okay, we're going to pop back into this. I'm saving this till the end. I can't do greasy hands with this. Okay, so let's get into what F# actually is. Well, it's kind of 2 things. Am I good to go? Okay. So F#, this is the fancy F# logo. F# is a functional language, so it's kind of like Scala, Erlang. Let's pop back. Haskell, Elixir, any functional language. But it also exists in the .NET framework, so that makes it part of the .NET framework, just like C#, VB.NET, kind of like what I just said. It's like functional languages, but also these languages as well. And that kind of makes F# a nice, powerful language, because one of the big things you can do with that is, we're going to talk about the .NET framework first, but one of the cool things about F# is that because it exists in the .NET framework, you can use tools in F# that you've actually written in C# or VB.NET or some other language that will exist in the .NET framework. And I'm going to show you an example of that. It's really cool how that works. So before we get into that, let's talk about, I know we've probably got a decent grip on what it means to be a functional language. We're going to review that in a minute too anyway. But let's talk about what it means to be part of the .NET framework. What does that actually mean? So I like to think of it more as an ecosystem than a framework. Frameworks to me are like Ruby on Rails or Java, Spring, Django, Angular JS, those kind of things, tools for a language. This extends beyond a single language, so that's my personal preference. I like to say the .NET ecosystem. But what it means to be a part of the .NET framework are, you have to follow what's called the common language infrastructure, which are kind of this set of rules. We're going to learn a lot of acronyms in the next couple slides. So what does it mean to be part of the CLI? Well, to be a part of the CLI, your code has to get broken down into kind of a bytecode language that's called CIL, which is Common Intermediate Language. This is pretty identical to how Java works, and then the JVM will run that bytecode. But instead of the JVM, you have what's called the CLR. I told you, a lot of acronyms. Common Language Runtime. That is basically synonymous to how the JVM works. It is your runtime that will execute your CIL, which is your byte-coded language. So, just to go through it one more time, we have the CLI is the whole kind of kit and caboodle, which means your code gets broken down into common intermediate language, which gets run on the common language runtime. It's a lot of stuff to take in. So here's a pretty picture that kind of details it a little more. You can see up at the top, we've got various .NET languages. You can pretend there's a nice F# document over here too. We got C#, VB.NET, J#. They've all got their respective compilers that will break it down into CIL, Common Intermediate Language. And this is what allows you to use other languages' tools in another .NET language. And then once it gets broken down into CIL, which is your bytecode, that gets run on the common language runtime, which is your environment that runs everything. So that's kind of how that's what it means to be part of the .NET framework. That's it. So, like I said, you can integrate various .NET languages together. We're going to do an example where we run some C# code in F# later on. And because it all sits on the .NET framework, everything gets broken down to the same language, you can use all these tools. So that's kind of what it means to be part of the .NET framework. I may be preaching to the choir, but I think it's good to kind of review the basics anyway. Let's talk about what it means to be a functional language, where I know I'm really going to be preaching to the choir. So we're just going to talk about some of the base rules, not spending a ton of time on this, but because F# is half this, half .NET, I want to spend a little bit of time on it. So what are some of the core concepts? Well, the biggest core concept is probably going to be that ideally in a functional language, you have pure functions. And this is kind of where my first two questions are going to be. I say no side effects. Who can give me an example of a side effect in a pure functional language? And you get a thing. Someone who doesn't have a shirt already, too. Yes, printing to the console. Perfect. Okay, I saw Clayton's hand back there. Do you already have a shirt, Clayton? Yeah. You don't get to answer. Unless there's extras. Yeah. So get a little bit more specific. Can I mutate? What kind of state can I not mutate? Yeah, perfect. State that is outside of your kind of existing scope. All right, did you want to add anything, Clayton? No shirt, but? Yeah. Other things include writing to disk, writing to a database, those kind of things. You just, ideally, in a pure functional language that uses pure functions, you can't do those things. The next thing is you have to abide by referential transparency, and this is my last question. Who can tell me, who doesn't already have a shirt, what referential transparency actually means? It's a fancy word that you can use at a cocktail party, and you'll be smart. Don't worry, if no one gets it, we've still got one. You've already got a shirt. Okay, Jordan?
All right, it means that if you put an input into this function, you get the same output for every value that
Yes, that's perfect. I'm going to throw this over here, and you can grab it. There we go. When I throw things too far, they get in pizza or drinks, and it's a bad situation. So Jordan hit it right on the head. Here's an example. You've got a function foo with no arguments. Every time you call function foo, it's got to return 8. That means you're abiding by referential transparency. If you pass in an argument, let's say 5, and it returns 0, that's okay, as long as every time you pass in 5, it returns 0. That's basically anytime you see this function call, you should be able to swap it out with 8, and it works. You might think that this may seem obvious, but there's a lot of times where this won't happen. So example where you're modifying state, well, if you print to the console and you return 8, that doesn't work because you can't substitute foo with printing to the console and returning 8. That's modifying state. That's not in this area. Another thing you can't do is you can't really use random numbers. If foo were to return a random number each time, it's not referentially transparent. The last kind of thing that I want to talk about is just immutable variables. In a pure functional language, ideally, well, you can't mutate variables. Once they're set, they're set. All of this is to kind of say that most functional programming languages won't be true. They won't abide by these true principles, because this is kind of a big epiphany for me. If you think about it, if you have to abide by all these rules, your program, and I'd love to be challenged on this because I hope that I'm wrong, but your program, if you abide by all these rules, your program will more or less be a single function. It does one thing. You wouldn't be able to write a full web application that takes user input, because that's something else you can't account for. You're kind of limited in what you do. If you have one thing you need to do, or a series of things you need to do, that just processing things, that's perfect. But that's kind of why a lot of languages like Haskell even, Scala, F# is a perfect example. They're not pure functional languages. Because you can do things like print out to the console. So. They're the same thing, in my mind. Maybe not. Maybe pure functional language is kind of this ideal to me. I would love to hear of a pure functional language that abides by all these rules where you just can't do anything else. And again, love to be challenged on this. I think I'm meaning them to be the same thing, but if I just say functional programming language, I'm just referring to things like Haskell and Erlang and Elixir. I'll try to not use true and pure interchangeably. So F# is not a pure functional language by any means, and we're going to get into how it actually works. So we'll start off with a little demo. I'm going to pop over here. So I'm going to run just the F# interpreter right now. And how do you define a variable in F#? Well, it's going to be let x equals 5. In the F# interpreter, I have to end it with double semicolons. I'm not quite sure why, but that's why you'll see that. So we've got x is 5. This is how we define a variable. Yes?
Sorry, is this not running on mono?
It is running on mono. And I'm going to get into that a little bit later. But give me 5 or 10 minutes. But yes, I'm running the mono environment on my Mac. And you'll see me actually using the mono keyword here in a bit. So I'm running, we've got our variable x. We can print that out. You'll notice I did not give it a type. But it actually is statically typed. So that might sound kind of confusing to you. Well, F# is actually using what's called type inference. It infers the type. If I'm passing in a data type of integer, it's going to automatically set x to an integer. And you can kind of see that right here in the signature of the variable. If I want to redefine x to actually assign it to a value, it's this kind of backwards arrow here. I'm going to try to do this. And it's going to say, no, you can't do that because it's not mutable. So we're kind of abiding by some pure functional principles here, but it is possible to set x to something else. Before we do that, though, in F# we can do something called shadowing. We can just completely redefine x to equals 10, and that's fine. X is now 10. We didn't redefine the same variable. We actually created a new variable at a new memory location. It just happens to be called x as well. If we actually wanted to redefine x, we're going to have to create a new variable and set it to mutable. Let mutable y equals, say, 10. So keep forgetting that. So y is 10. Now that we've defined it as mutable, we can actually set it to 5. And if we print out y, we've got 5. So a little bit of F-sharpness. Let's get into how you actually define a function in F-sharp. And I'm going to pop over to my editor here. This is going to be my little area where we'll execute some code using the F-sharp interpreter. And we'll code up here. So I'm going to add an example here. I meant to delete that, I think. Let me delete that because that's the one we're going to create. Okay, so this should be empty now. Okay, so let's define a little function. I'm going to add this keyword module at the top. That'll just allow me, whenever I put it into the interpreter, the REPL down at the bottom, it'll be easier to use. So if I want to define a function, it's very similar to how we define a variable. It's going to be let. We'll create a function called add, and this function will accept, this will be a simple addition function. It'll accept 2 arguments that we just add together. So we'll call it x and y equals. Now F-sharp is a syntactically significant white space language, so you're not going to see many brackets, you're not going to see semicolons, you're just going to see tabs. So right now, we're inside of this function. There, we're not, and we'd get a syntax error. Now we are. So we're just going to call x plus y, and that's it. There's our full function. In F-sharp, you don't have to specifically call return. It's kind of like Ruby, where the last line of something is going to be your return value. And there's other languages that do that too. So this is our function right here. And actually, let's actually use this. I'm going to run F-sharp interpreter. So I'm going to load this file in. Oh, I forget what directory I'm in here. Let's see if I'm in the code directory. Yep, I'm in there. Okay, so you can see we loaded that in, and we're not specifying any types right now, but you can see F-sharp is saying, hey, you're going to accept an integer, and you're going to accept 2 integers, and then we're going to return an integer. The way it knows that is by type inference, kind of like what we talked about earlier. So if I'm going to call this module math.add, and I'm just going to pass in 5 and 6, we should get 11. It's magic. You'll notice we didn't need to pass in parentheses. Same thing up here. If we were to have passed in parentheses, that kind of sets things as tuples, so kind of lists of items. Unless you put parentheses around each individual argument, then it's kind of a tuple of 1, and that behaves in a similar way. Yeah?
So I don't see it. Is it the only thing that you can like add together? Because I see that it's inferred.
So, very good question. So let's say, for example, the plus operator works on strings too. We can concatenate a string. What happens if we put in, we want to add foo and bar together? Well, we're going to get an error because, let's full screen that. It says the expression was expected to have a type int, and you pass in a string. Well, this is completely valid. We're just concatenating 2 strings together, so what's happening? Well, F-sharp will infer the type, but if a situation like this arises where it's inferring the type that you didn't want it to, you can explicitly pass that in. So these are what are called type annotations. So I'm explicitly saying I want this to be a string value, and I want this to be a string value too. I'm going to wrap these up in parentheses, because if you use a type annotation, they've got to be in this format. And so we're still passing in just 2 variables, but now if I reload this function, this file, you can see our function signature changed. We're now expecting a string, 2 strings actually, and it's going to return a string. So now my function call earlier will actually work. We just concatenated strings together. So that's how type annotations work in F-sharp. Kind of the next thing I wanted to get into is kind of more how this fits into the .NET framework. So I'm going to go.
Sorry, are returns or indents used to identify function blocks?
To identify a function, so you can actually have a function with no parameters or no arguments. That's not what I wanted to do. This is a valid function here, and yeah, the only difference between a variable and a function is that logic will happen at an indented pace, at an indent below the actual function call. So yeah, they're pretty much identical to a variable. Just if you have the indent below that actually has some logic, that's a function. And you don't have to return anything, but by default, the last line will be a return statement.
So you couldn't
yeah.
define that?
What?
You couldn't have that in a single line?
Oh no, that would work too. I see what you're asking. Right, because I removed that. Oh, yep. Okay, so no, that works too. That's a good question. I never thought about it. I guess F# must, if there's logic that follows it, it must just define it as a function. Or maybe it just runs it all as is. Maybe a variable can just have logic anyway, but if it's a variable, if it doesn't have logic, then it'll just kind of act as a variable. Zach, did you have a question? No, that's just what I called it to be able to say. By default, if you import something into the REPL down here at F#, I think it is called your program name, and that just gets confusing. So if you specify a module at the top, then you can just say math.add.
So when you had it so that you define the x and y parameters as strings, why did it choose to make an int versus, like, because x plus y is bound to string.
Right.
Why did it choose int?
I imagine it's just got to have kind of a list of priorities for each operator, and I'm guessing an int must kind of be prefaced by string. That's my guess. Yeah, good call, Jordan.
So what if one of those variables was a string and the other was an int? How would it know?
So the question was, what if one variable was a string and one of them was an integer? And I haven't explicitly tried that, but I'm pretty sure I know what's going to happen. Let's see. I wonder if we'll even be able to load this.
Also, why are the why are you using semicolons after each?
So I mentioned that at the beginning. I don't know why F# interpreter requires me to do that. That's just the question was, why am I adding in 2 semicolons at the end of every call here? F# interpreter requires that. I never dug into why that is the case. It's not. You don't need to validly put that in your F# code. But I like the question you just asked because I'm going to segue into a little bit more of my presentation. Yeah, Clayton?
Sorry. Can you map multiple adds that take different kinds of arguments in the same module?
You should. The question was, can you pretty much overload the add method? Are you saying if you were to have it?
So you have let add x, y, string, and you have also let add x and y and which one gets called be determined by the kind of arguments that are passed.
Right. So overloading a method, that should be, well, let's just give it a quick shot. That should be perfectly valid.
So make the second one an int and the first one a string.
Okay, so you mean different types. Okay, let's try that. And then we'll segue back into stuff.
Sorry to be wrong.
Yeah, let's see what this let's see what this does. I'm curious. So, okay, so we get an error. We can't have define two different things, which makes me then wonder what happens if we just, delete one of these and we overload it. Can we do that? Nope, we can't do that either. We can't overload an F#. I learned something. Cool. Okay. So, kind of segueing back to your question about the type safety, how that happens in F#. So, I've kind of mentioned already that F# is a statically typed language, which makes sense because it gets broken down into bytecode. There's a compile process. Because a language is compiled in some way doesn't always mean that it's statically typed, but it's a pretty good indicator that it probably is. But here's kind of so this is how we define a variable. Is this strongly typed or weakly typed? And I think this is where this will trip a lot of people up. A lot of developers will think that because we're not explicitly saying that a variable, what type this is, that it's weakly typed, and that if we did specify that, using type annotation, for example, would that make it strongly typed? And the answer is no. You can't tell by this whether this is strongly or weakly typed. Saying something is strong or weakly typed refers to type safety, and what that means is that the age-old example is if you add a string and an integer, will it error? In a strongly typed language, it will error, and as we kind of saw earlier down here, right up here, we tried to add an integer and a string together, it errored. So F# is a strongly typed language, even though we don't explicitly have to say the type. The only thing that you really can tell by this is that if it's a statically typed language, that it's using type inference. So it's going to infer the type. It's going to behave as if you had specified a type on the backside. It just infers it for you if you don't specify it. So we're going to get into higher order functions, but in a second, I want to do a couple little demos of how you can actually use other .NET language type things using F#. So I've got one function here called replace. We're going to call it module replace. This module didn't exist. It's just what we're going to call it for now. This is a comment in F#. It's incredibly intuitive, right? And my syntax highlighting is failing on it, so that makes it even more intuitive. But the parentheses star, we're defining a variable. We're defining a function. We're passing in one string argument, and we're going to call this .replace function. It's called toHackerTalk because we're replacing all the T's with 7s and all the O's with 0s, and that's it. And we're returning it because it's the last line of the function. My point here is that .replace, that function that we're calling, could have been written in F#, or it could have been written in anything else, and that follows the .NET framework. It doesn't matter. So if we want to load this file, just so you can see what it does, I'm sure we all kind of can pick up on it. Oh, that's demos, yep. I mess up quite a bit when I'm live coding too, so I'm trusting everyone here to watch out for me. Okay, so if we call replace.toHackerTalk, and we'll just put in the code boss, we get all the T's replaced with 7s, all the O's replaced with 0s. It's magic, I know. So I mentioned that this doesn't have to be F#. This could be written in another language. So what if we want to do that ourselves? Well, over here, I've got this function, or this file, called arith.cs. That's a C# file. I know we may or may not know C# here, so we'll walk through this briefly. We have a namespace, mymath, and inside there, we have a class called arith. And inside there, we just got an instance method called add. So, keep it along with the theme, we're just going to add two things together, an integer x and an integer y, and we're going to return that. So we could create an instance of this class, call .add, give it 2 arguments, and bam, it adds 2 integers together. Well, I've got another file over here called arith.fs, which is, I haven't said it yet, but that's F# file. That's the file extension. We're going to call, it's going to be the same module name, strictly so we can use it in the interpreter easier. We're going to call mymath.arith. Well, arith is not defined anywhere in here. This is actually going to be defined in the C# file, right here. So we're going to create an object out of it, and then we're going to just add it together, 10 and 20. F# does have classes. That alone kind of makes it stateful programming. They're not used heavily, but you can use them, especially because it fits in the .NET framework. You can use them from C#. So let's actually run this. Well, right now, if I try to run it as is, it's not going to work, because if I try to run this file, it's probably going to throw an error and say, I don't know what arith is. Okay, yeah. It says the namespace of module mymath is not defined. It's trying to call that right here. So let's actually, what we're going to have to do in order to use this C# file in our F# is we're going to have to build it. We're going to have to build it to CIL, common CLI, oh man, I can't even remember anymore. The common intermediate language, that's CIL. Okay, so let's do that. So I'm going to hop over to a console here, and that file is located in the demos directory. So what I'm going to do is I'm going to build that into a CIL file. So to do that, I'm going to use Mono, which this is going to be Mono C# compiler. So Mono, many of you may already know, but typically .NET has historically not been able to run on anything but a Windows machine. That's changing with .NET Core, but if you still want to use something that's not part of .NET Core, you'll still need the full implementation, which Mono is a cross-platform implementation of .NET. So that's what everything that I'm using is running under. That's kind of the environment that I'm running everything as. So we're going to use this tool, Mono C# compiler. And we're going to pass in what we want to compile, which is going to be demos arith.c#. And we're going to say, I'm just going to print it out to that build directory up there. And we're going to call it arith.dll. Whenever you build files in the .NET environment, you can build 2 types of files, .dll files or .exe files. I'm sure we may have heard of them from back in the day. That error is expected. I'm going to get into why that is. But the difference between them are exe files are executable. Those are the things that actually run. DLLs are dynamically linked libraries. They're just code that gets attached to an exe at some point. Well, by default here, let's look back at the C# file. This right here can only really exist as library code because we don't have a main method. By default, when I try to build a file, it tries to get built as an exe file, and that won't work. So what I need to do is specify that I want to target it as a library, and that will actually build it out successfully. So now if we look in build, we've got arith.dll. This is a CIL file. I can use it now in F#. So it's built. And what I can do, I'm going to actually import it into my, my F# REPL here. So I'm going to use, instead of load, I'm going to require this because it's an assembly. And we'll require build/arith.dll. Yep. Spelling is my strong suit. And there we go. Just to kind of full screen that for a second. It says we reference this file. File may be locked by this F# process here. So we've got that loaded in there. And now we actually can load this file. And you can see we loaded everything successfully. So now I can access, I've loaded both things in. I can actually access the C# code directly, or I can kind of, if I want to, go to this arith.fs, underneath the mymath module, x has been defined. So if I were to print out mymath.x, it should return the value that this returns right here, which what happens when we add 10 and 20 together? We get 30. It's magic. We just use some C# code in F#. And this is, you know, that's right. That's right. So I think this is kind of one of the coolest things about F#, is the fact that it exists in this ecosystem that allows you to do this. If you are using a language that runs on the JVM, you can do this too. You can use other tools that exist on the JVM or any common environment. The JVM is, which is the Java virtual machine, is kind of just the most common one out there, and a lot of languages have implementations for it. So this is how F# exists in the .NET framework. Let's get back to the presentation real quick. Let's talk about what higher order functions are. I'm sure a lot of us know this, but higher order functions can be one of two things. They can either, one, it's a function that accepts another function as an argument, or it's a function that will return another function. And there's a lot of common higher order functions, but there's kind of three big ones that I think are very important to know. And these are language agnostic. You'll use them in any language. And I think Elliot talked about a year ago about these three functions in one of his talks, and they're really good to know. And a lot of us are probably familiar with maybe map and filter, maybe not so much fold. That one's kind of a little bit different, but we're going to hammer on these hard and how they actually work in F#. So let's talk about map first. Does anyone know what map does? I don't have any more shirts, but you get the spotlight for a second. Map syncs? No. So a map is where you have some type of an iterable, and you apply a function to that iterable, and you're doing something to it. Let's say you have a list of 1 to 10, and you want to just add 1 to each of those functions. You can map through them and just say x plus 1 is that's going to be the function that you pass to them. You get out the same iterable, but just all the values have been incremented by 1. That's a common example of a map, and we're going to do something simple like that too in F#. And we're not going to run this one through the REPL. We're going to actually build it and run it through Mono, so you kind of see how that works too. So we've got map.f# here. And in fact, we are done with this down here, so let's exit out of that. Okay, a little bit more screen real estate. So here's kind of an example of map functions, and we're going to learn a little bit more about F# too. So we've got a little variable up here. The quick brown fox jumps over the lazy dog. That's a function. That's the sentence that has every letter of the alphabet in it. That one's nothing crazy going on here. We can assume that it's going to be inferred as a string type. This is kind of where the craziness starts happening. So we're going to define a variable called histogram. And what we're doing is we're going to take this data, the string, and create a character array out of it. So it's going to be an array of T, comma H, comma E, space, etc. A very long array of all the characters. And then here's where we get into things that we haven't seen before. So here's one of the really neat things about F#, and a lot of languages can do a lot of functional languages especially can do things like this, but this is called the pipe forward operator. And what it will do is it will take whatever you're passing into it, which is going to be this character array, and it's going to send it into whatever function you're executing the next time. And it's going to pass it in as the last argument. So sequence group by, for example, is the function call, and it accepts a function here, and then the last argument it will accept is going to be the list that you're actually trying to group together. Well, we don't have to specify that because we're piping it in. In a way, it's similar to kind of the shell pipe operator. Not identical, but the logic is kind of similar. So let's step through this. So we got this character array. We're going to group these up by their actual kind of letter. So this is going to group together C and then list together the amount of C's together. So I don't know how many C's there are in here. It looks like just one perhaps. So it's going to be a key of C, and then that's going to have an array. A sequence is the data type right now, and it's just going to be one C in there. If there were 3 C's in here, it would be a key of C and then 3 C's. The point is we're creating a sequence data type, and we're kind of grouping them up by the actual letters. Now here, then we're going to pipe that into map of sequence. All this is doing is transforming a sequence data type into a map. And this map is, it's confusing documentation, but this map is going to be an associative array. It's going to be a key value pair thing. This is not the map function we've been talking about. And this next line is even better. It's map.map. So we're going to pipe this now as a map right here, and that's going to be a true. We're not in the sequence data type anymore. This is going to be a true key of C, and it's going to list all of the C's as an actual array. And then here's where we actually have our map function. We're going to iterate through it. So we're calling map on what we have right now, which is a key value pair. And we're going to iterate through everything, and we're passing in the key and the value here. And then we're going to just get the length of the actual value, which right now, up to this point, the value has been just, the number, the total, C's or whatever letter you're in. If there were 3 C's, it's just been C, C, C. Now we're going to actually return the length of that. So it's going to be a key value pair of C and then 3, the amount that actually appeared in here. A lot of stuff going on here. And understanding the logic is not the big part. The point is I just kind of wanted to show off the pipe operator, because you can really chain together some really neat functions doing this. So here is we've kind of got our histogram here. And this part is a little bit easier to understand. We're just going to iterate through the key values in the histogram, and we're going to print them out. So it's going to print out, however many times this letter showed up. Let's actually see what that looks like. So we're going to go here. So these exist in our demos file. So we're going to do something similar to what we did earlier, but instead of doing mono C# compiler, we're going to use the F# compiler, which is F#C. And to do that, we're going to call demos map.fs. We need to specify, actually we don't need, this one can be executable, because in F#, you can just write a script as is. You don't need a main method like you do in C#. It'll just go top to bottom. There is a decorator called entry point, which you can specify where you want your script to start, but if it doesn't, if you don't have that, it'll just go top to bottom. But we do want to specify just the out location, just because I want to keep it all nice and organized. Okay, apparently, I think it may be 2 dashes. Okay. And mono C# compiler is 1 dash, F#C is 2. You gotta love it. But if we look in the build directory, we've got a map.exe file. Now we can't just run that. We could if we were on Windows, but my Mac does not know how to handle .exe files. So what we can do is we can use the actual mono keyword. This will spin up the mono environment, which is going to be the common language runtime, and we can run map.exe, and we get what we were expecting. We're just going to print out everything in there, and again, there should be something for every letter that appeared, case sensitive right now. We've got a lot of spaces. We've got 3 E's, 4 O's, etc. And this is just kind of a little example of how map works in C#. Again, we just iterated. We kind of went through an iterable, and we just applied a function to it, which right here was just getting the length of something, getting the length of one of the value in the key value pair. Yes.
Are all your functions automatically curried?
I don't know. The question was, are all the functions automatically curried? I don't know.
Like sequence.group by, and then you're passing in a function, and then it still expects another parameter, which is the array, right?
Yes.
If you just said sequence.group by and pass in a function, would that return a new function, do you know?
It would. No. Sequence.group by, if you just call this, that would not be a valid function. It expects a second argument just because we're using the pipe operator that's piping it in at the end. The pipe operator does more than that. It spins arguments around, but I don't want to dig into that mostly because I would botch it up like crazy. Okay. Also, before we get to your question, Dylan, I never mentioned that these are anonymous functions. Those exist in F#. I assume we all probably thought they would, but this is how you can do an anonymous function. Fun this, your argument list, and then whatever the logic is after that. Yes? So let's just kind of, I printed this out earlier, and it prints out like a key value pair of, or maybe I'm thinking of the map. I think the map generates the key value pair. A sequence is actually just a single data type in F#. And I couldn't really liken it to, a lot of errors there. Do I have something open right now? Let's just reopen this and try again. Let's just close down everything and try again. Let me see. Oh, it's because I have this this open, I bet. Okay. That's not how we do that. I think that's right. Oh, I'm up a directory. Okay, so looks like we got an error. Oh, the namespace violation. I guess maybe I do need to do this for every. Yes, yeah. So there are lists. Lists would be a better option, but this kind of specifically sets up. It sets up a key, and then you kind of have the second. It's not a key value pair, but it can be transformed into a key value pair very easily. The first kind of part of it is a key, and then the second part of it is an actual sequence of whatever you passed in, so a character sequence here. But then we can actually convert this to a key value pair. I'm not crazy familiar with sequences, so probably not going to be answering many questions, but. Yeah, it could be. Okay, I'm going to jump to filters now. I'm going to close this again. So filter is kind of the next big question. It works similarly to map in the fact that you're applying a function to an iterable. All of these are going to be like that. But the big thing with filter is that the function is expected to return either true or false. If it returns true, then you keep the item in the new array, the new iterable that's being passed. If it returns false, then you just ditch that item. So a common example of filter is if you have a list of 1 to 10, and you wanted to filter out all the even numbers, or keep all the even numbers to where you're filtering out all the odd ones. Well, your function would just say, is this number divisible by 2? If it is, return false. If not, or if it is, return true. If not, return false. And then you'd get a new array of just 2, 4, 6, 8, 10. So let's see an actual example of filter in F#. We're going to use a lot of the same. I'm going to bring this back to what it was. Okay. Very similar stuff. We're going to just do a little print statement here. We're going to create a map of a list here. So this is an actual list. And this is kind of, I don't think they're called list comprehensions in F#, but I like calling them list comprehensions because that's what it is in Python. And it functions very similar. So we're just kind of iterating through a list. And I think my example I gave was verbatim what we're going to do here. No, we're not. We've got a list of 1 to 10, but then we're creating a tuple of that number, so 1, for example, and then the square of that number. So we're going to have a list of tuples. It's going to be 1, 1, 2, 4, 3, 9, etc. And we're going to pipe this list of tuples in here, and we're going to actually iterate through them. And what we're doing here, we're creating the map of them. So this is actually going to pass in the key, and then the second value we don't care about because that's going to be the square. And again, we're just trying to test for if something is even. So we're going to just ditch that, and then we're going to check can you mod it by 2 and have it be 0. One tricky thing of F# is the equal symbol is comparison. It's not double equals, it's just single equals. If you saw earlier the little backwards arrow, that's how you do assignment. Except if it's a variable. Get that, because you can see up here, we're still doing equals. F# is weird. Okay, so we're kind of filtering here. So we're still generating that map, and we've just filtered out the ones that we don't want, and then we're actually iterating through it to do something. So here we're going to print out you know, that all the even values and their squares. So if we run this, so let's build it, kind of like what we did before, except instead of calling it, here we'll just. Okay, can anyone see that? I know it's at the bottom. I like to keep things at the top, but I failed here. But you can see we're printing out all the tuples here. Or I guess at this point, they're not tuples, they're key value pairs. Initially, they were a list of tuples. But these are just key value pairs of the actual integer, 2, 4, 6, 8, 10, and then their square. So an example of how filter works in F#. The last thing I want to talk about as far as higher order functions go, and then we'll end on how async works in F#, because that's pretty neat. Folding is kind of the last function. And this one has got a lot of different names. It can be fold, reduce, inject, aggregate. It's got a lot of names depending on what language you're using. And this one is, I think, the least understood of the three. But it's really powerful if you have a use case for it, which is a lot of the times more often than you think. So here we've got a map. We've got a list here, and then we're going to create a map here. So that's going to be a key value pair right here. It's going to be 1, and then a string of 1, 2, string 2, 3, string 3. We're going to fold through this, and you'll notice we're not using any pipe operators here. The way fold works is it's going to accept 3 arguments. It's going to accept the function that we're going to fold through. The way fold works is you have a base case. 0, for example, is what it is here. And then you're going to have an iterable, something you iterate through. That's map 1 right here. And then you're going to apply a function to that iterable, and each time you do that, you're going to update kind of your aggregator value, which is going to start off at 0 here. That's your base case. The idea is you're going to run this function on the first item, and then your aggregator is going to change. And then you're going to run the function on the second item, your aggregator is going to change again. It's kind of confusing if you're not familiar with it, but it's pretty powerful. So let's take it step by step what's happening here. We've got a map of the keys are 1, 2, 3. The values are just string 1, 2, 3. We're going to iterate through, let's iterate through the first item, which is going to be 1, comma, string 1. Our base case is 0, as you can see in the second argument. And what's happening here, we're passing in 3 variables. The first one is going to be the state. That's the current aggregator. So 0 will be the first state. Then key value is going to be, because we're iterating through a key value pair, so those get set. So key will be the integer 1, and then value will be the string 1. But we're not even going to use value in this function right here, because we're going to sum the keys together. Ideally, we're going to have 1 plus 2 plus 3. I can't do that math on my own, so I need to write a function to do that for me. And we're going to do the current aggregator, which is state, which is 0, plus key, which is 1. So at the end of the first iteration, we've got an integer of 1. Well, that's going to get passed in to the second time we do this function, this iteration. So state's going to be 1 here. Key value is going to be 2, and then the string 2. So this is going to be 1 plus 2. And then the state's going to change to 3. So on our final iteration, state's going to be 3. And then the key and value are going to be 3, and then the string 3, which we're not using. So we're going to get 3 plus 3, and that should give us 6. Magic. And then we're going to print that out right here. And we'll go through that second part here too. It's the exact same thing, but with strings. But let's just print out to show that I'm not crazy and this actually works. Let's clear that. Let's see, could not build. What? Thanks, guys. Winning. Okay, so the first one is 6, and so that's correct. It worked as we expected. Winning again. Second one is going to be 1, 2, 3. And we'll kind of blaze through this one because it's the same logic. We're doing the exact same thing, same iterable. The only difference is that our base case is now an empty parenthesis because 0 doesn't work with strings. If we try to add 0 in a string, as we saw with type safety earlier, that would fail. So our base case is an empty string. Instead of using key in here, we're going to just add value. And then we're going to add in a space too. So it's not just 1, 2, 3 all smushed together. iterate through that 3 times, the aggregator gets added. I think a common misconception is that people try to use fold or inject or whatever your language calls this function. They try to use it just for integer purposes because an aggregation kind of makes sense. You can use it for a lot of different things, and it's really powerful when you get beyond that hump. For example, if you have 5 functions that are all modifying parts of the same data structure, and you pass in the new data structure to those functions each time, that's kind of a fold right there. You can just fold through the functions. A list of functions can be your iterable. You can think about it in different ways. So the last thing I'm going to talk about, we got 5 minutes left, I'm not going to hold you over or anything, is how concurrency works in F#. So concurrency in general is different from parallelism. Parallelism is specifically actually running code on multiple different cores of your machine. It's truly parallel, running at the same time as other code. Concurrency is kind of this umbrella. It includes parallelism, but it can also be code that's just executing, in time slices, for example. Let's say this part of my program is running now, then I want to stop it and then run another part of my programming. That's still concurrent, it's just not parallel. You can run concurrent programming on the same core, just they're not running truly at the same time. Well, in F#, the most common way to kind of use concurrent behavior is to use asynchronous behavior. So you're kind of, send something off to do something, while that's returning, you're doing something else. So that's what we're going to do a little example of. I don't know why my editor does this thing, where it does that. Anyway. Okay, so this looks a little bit longer, but it's not crazy long, just 30 lines. So we're going to open up some modules here. This is how we use the modules that we didn't define, and these are just going to be part of what Mono has as core. We've got a list here, and this is a list of key value pairs. So because you can see there's not a comma at the end there. So Microsoft.com is going to be our key. This is our value here, MSDN, the URL, etc. The purpose we're trying to do here is we're going to hit these URLs and wait for a response and see how much data we get back from them. So this is asynchronous behavior because we're requesting information from third-party sources. So I've got a list here. We've got a function here called fetchAsync. It's going to take a name and then a URL, which we're type annotating to string. Just wanted to showcase how you can do it with or without type annotations. And it's got this async block here. Now the way async works is even if we were to call this function fetchAsync, and if there's an async block in here, nothing in here is going to run until we tell it to. This is just going to return an async block. So what happens when we actually want to run it? Well, let's go down a little bit. So the very last line is going to call this function runAll. Well, runAll is going to take our list, as you can see up above. It's going to pipe it to actually map through fetchAsync, which still is not going to do anything. We're going to pipe that to async parallel, which is still not going to do anything. This is just specifying that we do want to run this in parallel, which I have multiple cores on this machine, so that'll work. If we didn't, it would just simulate parallel. It would simulate concurrent behavior. It would still work. The async block doesn't get run until we have this async.run synchronously happen, and then we're just going to ignore the output. So nothing actually does anything until right here, and then this will actually get run. So what this is going to do is we're going to have iterated through this function right here, or this list right here, and for each time we do it, we're going to pass in the name and URL. We got a try catch statement. It's not a catch statement, it's a with statement. That's the same. It's the same concept as a catch statement. We got this fancy pipe down here that'll just allow us to handle different errors in a different way. You can handle patterns differently. Right now we just have a catch-all exception, which hopefully never gets called. And inside of this async block, we're going to, at this point we've already defined the async behavior. We're defining, a variable here that we've kind of imported from our modules. This part right here is different, the let bang, let exclamation point. What that's saying is that this actually is an async process, async download string. So if we were to run that, the program would keep running after that. But the let bang is saying we want to just wait for things to happen, which is okay because it's already running asynchronously. So we're not holding up any other processes. We're just kind of holding up this process, which we need. We're gonna take the response and we're gonna print out how it actually runs. So let's actually build this and run it. see if I can spell build. There we go. It builds successfully. So you see things coming in at different times. That one sure takes a while. Okay, so we got some data back from all these sources, and this is how you can do, you don't have to use async blocks like this, but this is, as far as concurrent behavior in F#, this is by far the most common way that you will see it written. So that's kind of the big thing, that's kind of the big ending I have, which is perfect because we're at 12:29. We did it, guys. We learned a little bit about F#. That's all I got. There's me, there's my website. Thanks everyone for coming out with all the rain. And I'm here for questions that I probably won't know. If anyone has any? Yeah.
I've been thinking about your after talk example.
Mm-hmm.
Are those strings passed by reference or by value?
Oh, I never dug in. The question was, are strings passed by reference or by value? I'm going to assume they're passed by value.
The reason I ask is if they're
Where are we
passed
at?
by value, they create a mutable or an immutable variable. And the reason I ask that is if you're bringing in replace from like C#, say replace changes your string in place, you just get an error at that point every time you try to use it, right?
Right. I'm pretty sure, so I haven't dug into this, but I'm pretty sure replace will return a new string every time.
String operations in .NET are immutable, so they actually return a new instance.
Okay.
It is passed by value, but passive reference is by value. If that makes sense.
I'm sure it does.
All right, we're officially at 12:31. I'll let everyone go. If you have any further questions, I'll be here to say I don't know.
Yeah, real quick, thank you very much, Aaron. I've seen Aaron talk a number of times.